So I want to pick up where teacher Simone left off. Hello, Justin. Amazing to see you. Okay, so we're going to start with an easy-ish question. Okay, I want you guys to have a look at this question and tell me if you are able to do this question on your own. Give me a thumbs up if you're able to answer this question on your own. Okay, Oko says yes. How about everyone else? Okay, all right, amazing. So I'm going to give you guys about 4 minutes. I'll give you guys 4 minutes, okay? Actually, I'll give you 5 because this is 3 marks and that is 2 marks. I'll give you guys 5 minutes. Narisha, if you get stuck, please just pop me a message in the chat and then I can help you out wherever it is that you're stuck, okay? Hello, Didimalo. Amazing to have you here. I just want to move my camera. Sorry, guys, just a second. My camera to behave. There we go. All right, amazing. Okay, 5 minutes, guys. Give me an emoji when you're ready. Hello, Sanele. Hi, Sanele. We're working on the question on the screen. Okay, Mandisa's done, which is good. That's promising. Hello, Theo. Okay, I'm going to give everybody else 1 minute, and then we're going to get started on the question. Okay. All right, peeps, shall we tackle the question? Yes, are we ready? Does anybody still need a bit of time? I think we can answer the question, yes? Okay, all right. So first thing we're going, okay. Didimalo, 1 minute is a lot. I'll give you 20 seconds because you've got to be finishing up. All right, Didi Malo, that's all the time I'm going to give you. Okay, you can continue while we discuss the answer. Okay. All right. Okay. So first thing I'm going to do is I'm going to take this line over here and I'm going to extend it downwards parallel to my y-axis because I know that this is the y side, this is the x side, and that is r. Okay. Remember, guys, we're working with shade your rear. You can either work with Sokotoa or you can use shade your rear, whichever one you use. Shade your rear because x-rays shade your, no, tan your exterior. There we go. I must not forget. Because X-ray is tan your exterior. All right, so we can use this one over here. Now, I know that I'm going to have to find the length of side Y over here. And I know if I've drawn this parallel to my y-axis, that's going to create a 90-degree angle over there. So the first thing I need to do, the reason why this first question is actually worth 3 marks and not just 1, is because I first need to find the side y. So I'm going to go y squared is equal to, actually, let's not, that's grade 8 stuff. We're going to go y is equal to the square root of the hypotenuse r minus squared minus the root of 3 squared. Okay, what did I use here? What is this thing called? What theorem did I just use here? Papyrus. It's Pythag. Good. Okay, good. So we're all aware that ma'am has used Pythag. Excellent. Okay, so the answer I would get here, I would get 4 minus 3, and that would give me the square root of 1, so y is equal to 1. So I now know that the side over here is equal to 1 unit. All right, from there, then I can answer what sine of theta is. Sine of theta would be the y value over r, so 1 over 2. And that's what makes it easy. So you would get 1 mark for that whole statement, 1 mark there, and 1 mark for the answer. All right, 4.1.2 is going to require us to do a little bit of calculations, but it's not that bad, right? We know what sine of theta is. Sine of theta is a half multiplied by cos of theta, which would be x over r, so multiplied by root 3 over 2. And do not punch this into your calculator, just give them the answer exactly the way that you see it. Multiply the top with the top, multiply the bottom with the bottom, so we should get root 3 over 4 as an answer. So 1 mark for that and 1 mark for the final answer. How did we do out of 5? Did we manage? Yes, 5 out of 5? Good. I'm seeing quite a lot of 5s. Everyone else, remember to tell me the truth if you didn't get 5 so that I know where to help you. Okay. All right, awesome. Can I step it up a notch? Didi Malo, is that a question, my darling?
Ma'am?
Yes.
Isn't theta an angle?
It is an angle. It's this angle that they've given us over here.
So, ma'am, don't we
Yes.
shift angle when we have to calculate?
No. Okay. Let me explain something here. If they say to you, find me sine of theta, what they want you to give them is something over something. Okay. But if they just say, what is theta? Then you know that you're looking for the angle. Okay, So over here, because they're asking us for sine of an angle and sine and cos of an angle, we just give them something over something. If they had said to us, determine theta, then we know that we need to shift angle.
Yes, ma'am.
Okay, all right. That's a good question, by the way. Thank you, Didi Malo. Good. All right, if they just ask us for the angle, then we shift angle. But if they say sine of something or tan of something, they want us to give a ratio, something over something. Okay. Narisha, are you okay? Can I just ask, is everybody else's screen okay? Yes, thumbs up if you can see my screen and you're able to see everything I'm doing. Sure, Narisha, I'm not sure. It might be signal on your side. Maybe if you want to just quickly hop out and hop back in, that normally helps. Try that, my darling, and then come back in. All right. Okay. Can I throw a little bit of a curveball our way? Yes. Can I give us something a little bit more? Yes, let's try. See, I don't say no. Let's try it. Okay. So we're going to be looking at question 5.1. I want everybody to read. Just read the question. Okay. Just read the question. And once you're done reading the question, give me an emoji for, not that you understand, just ma'am, I read it. Okay. Abu with a sad face after reading. I'm sorry. Okay. Okay. All right. Don't fret. It's gonna be okay. All right. Shall we start at the beginning? Okay. So this particular question requires us to read quite a bit. So before I get to this question, I'm going to ask you guys quickly. If I said to you guys that I've got sine of the angle theta is 3/5, right? And I tell you that theta is less than 90 degrees. And then I give you guys a Cartesian plane. Which quadrant would this then fall under? If my theta angle needs to be less than 90 degrees, it needs to fall in quadrant 1. Are we all in agreement there? We're all good there? Right. It all falls in quadrant 1. Good. So I don't actually have to know what the angle theta is. I could calculate it, but that's not the point. What I do know is that my angle must sit here. That must be theta, because this is 0 degrees, this is 90 degrees, this is 180, this is 270, and this is 360. Full circle, right? So I know that if theta is less than 90, it needs to sit here. Then I'm going to draw that line that's parallel to the y-axis, the one that we're used to. Right. Now I know that sine of theta, sine is y/r, which means this 3 is the y value, which means it goes there. And this is the r value. It's the radius. So that value goes there. Okay. Hi, Narisha. All right. So if this is my y value, that is my r value. Can I calculate for the x value? Yes, thumbs up. Are we able to calculate for that? Correct. If we use Pythagoras or papyrus, Abu, I hope you're writing Pythag in your books and not papyrus, because you need to do the right things. Okay, good. So now let me give you guys this. I'm going to give it to you guys in a different way. I'm going to say 5 sine theta minus 3 equals 0. And I tell you that theta, let's say, or let me say 5 plus 3. And theta needs to be between 90 degrees and 180 degrees. Okay. What can we deduce by just looking at this question? What do we know? Good. Okay, Abu, you're onto something. Let's start with, what does this tell us? What does this part of my equation tell us, great hands? It says quadrant 2. Are we all in agreement? Not quadrants 1 and 2, just quadrant 2. Do you understand why, Tidimalo? Yes? Because theta needs to be between 90 and 180. The only way it's going to be between 90 and 180 is if it's on this side. Okay. Oh, actually, I'm going to change this very quickly. Okay, I'm going to change this to cos. And there's a reason. Sorry for that. I'm going to change it to cosine. Okay, Narisha, does that make sense? Are we okay? Yes? We're cool with that. All right. Okay, you see why. Good. All right, so now I need to figure out what my angle theta is. I know that theta will sit somewhere here, but I don't exactly know what it is yet. I know it's greater than 90 degrees, but less than 180. So it has to sit like that. Now, in order for me to figure out cos of something, I need to rearrange this. And Abu's not wrong. First thing Abu did was he took the plus 3 over to the other side. Okay, so now what we've got is 5 cos theta is equal to -3. What's my next move, great hands? Next move? Divide by 5. Good, we're going to divide by 5. Divide by 5. Good. Cancel, cancel. So now what I actually have is that cos of theta is equal to -3/5. Now, if we look at the quadrant we're in, if I put my negative over there, where does the negative belong? Does it belong to the 3 or does it belong to the 5? Which one would it belong to? Okay. The 3, good, good. I hope we're all in agreement. The reason for that is because we know that our r will never be negative. Our radius is never negative. It's always positive. So r will equal 5. And my x value, because this is cos, and we know cos x rays, the x is the top part. So x will be -3. And this part will be 5. And then can we figure out the y value? Yes. Thumbs up. Are we able to figure that out? Correct. If we use papyrus or if we use Pythagoras, we will get that the answer is 4. All right. I want to make sure that everybody's understanding everything that I've just explained here. Okay. Because if you manage to understand this, what I'm about to show you in that other question, we should be able to understand. All right. Let's go back. Let's look at the question. Look at the first thing. It says, the following are given. Look at what it says. It says 7 sine x is equal to 4, where x is less than 90. I'm going to ask before we continue. Can everybody plot 7 sine x equals to 4 on a Cartesian plane for me? Yes? Thumbs up. Are we able to do that? The way that ma'am just did this other one. Are we able to do that? Perfect. You've got 3 minutes, everyone. It's not that difficult. I want you to find me that value, and I want you to find me the missing side. Okay, so reconfigure the equation, redraw it on a Cartesian plane, and find me the missing side. And give me an indication when you're done. Okay, let me know when you're ready so that we can start the question. Okay, Princess is done. That's good. It's not as difficult, especially when you know how to read it. It doesn't become that difficult anymore. Yeah. Okay, excellent. Oh, beans. I like it. I like it. Everybody's getting it. Remember to say or to ask if there's anything that you're not 100% sure about. I'm happy to help, hey? All right, can we compare sketches? Are we ready? I'm going in. All right, so I'm going to draw my Cartesian plane. Okay, I'm told here that 7 sine of x is equal to 4. I know that I want sine of x, and it must be in the first quadrant because that's 90. That's 0. X needs to be less than 90. So it needs to be here somewhere. So that's my angle x. I'm going to draw my line like that. I know that this is sine. I'm going to divide both sides by 7. Divide by 7. So I now know sine of x is equal to 4/7. I know that the 4 is my y value. So 4 goes over here. And 7 is my r value, which is over there. And then I just need to find the x side there. I can use Pythag to do that. So I know that the side x is equal to the square root. Good. We're going to use Pythag. 7 squared minus 4 squared. It's going to give us something in surd form. Do not click SD. Leave it exactly the way that it is. Okay, this should be 49 minus 16 should give us 33. The square root of 33. Good. The root of 33. Good. You leave the answer exactly like that. We're not going to change it. So we know that this side over here is the square root of 33. Okay, did everybody manage up until this point? We okay, everyone? Even in the drawing, beautiful. Amazing. Okay, lovely. So that's step number 1 taken care of. That's step number 1. Okay, now the next step says tan y is equal to t. Okay, this doesn't tell us very much, except I know that when I have, let's say for instance, guys, I have tan of theta. I know that tan of theta should be opposite over adjacent, right? So if I told you guys that tan of theta is equal to 3, what does that actually mean for my answer? What does it mean? How do I get that to be a ratio? How do I get this 3 over here to be a ratio? Tan of theta needs to be good. That's it, Abu. It needs to be 3 over 1. Good. Amazing. That means tan of theta is 3 over 1. All right. So if we look at what they've given us in this next question over here, they tell us that tan of y is equal to t. Okay. Didimalo, because anything divided by 1 is that thing, right? 2 divided by 1 is the same as 2. 5 divided by 1 is the same as 5, right? So if I give you, let's say for instance, I give you sine of theta. We know for a fact, oh, it was just an example. It was just an example. Didimalo, it was just an example. Okay, it has nothing to do with the question. Sorry. Sorry, it doesn't have anything to do with the question. It was just an example. That's why I've erased it. That's why it's no longer here. Okay, sorry guys, I just need some space. All right, so if we look at this tan y that they've given us, they've told us that tan y is equal to t. How can we rewrite that? I can rewrite that as t over 1. Yes, everybody in agreement? Thumbs up. I can rewrite this. Tan y is equal to t over 1. Right, lovely. Now comes the part of the mathematics that many of us have forgotten all about. Okay, the next part then says x and y are complementary angles. What does that mean? We should know. We do this in grade 6, 7, and 8. What is a complementary angle? Beautiful. Now, I know that these two angles together must equal 90 degrees. Good. Right. Now, here's the thing. This is x. Does anybody want to unmute and tell me where y needs to go? Where would y need to go? Opposite it over here? No. In the triangle. Oh, so over here. That's okay, Abu. It's good. There we go. Narisha's got it. Narisha's got the right idea. Okay, so technically, Abu, I'm not 100% sure. Next to x, yes, that's exactly what I was looking for, right? Because these two things are two completely different triangles, y would have to go next to x, but next to it, right? Outside of the triangle with x, but next to it. You are spot on, Abu. You just didn't exactly know how to say it out. Good. So this over here must be y. Okay, the reason we know this is because if that's 90 degrees, if from there to there is 90 degrees, then this must be the complementary angle that they're talking about. All right, now we get to fill in all the things that we know. Right, I'm going to close up this triangle over here in that direction. Now, I've been told that tan of y is equal to t over 1. I know that tan is opposite, which would be over there, over adjacent. So this side then becomes t, and this side becomes 1. Abu, what do you mean? What do you mean when you say root 33? It can't be root 33. Oh, yes. Okay, I see what you're saying. Correct. Okay, good. Okay, I'm not sure everybody's where you're at yet, but we're almost there. Okay, we are almost there. All right, so this is as far as we've gotten. I just want to make sure everybody's on the same page with me. Are we all 100% on that? Yes? We all good? Amazing. All right, so here's my next question. With these two triangles put together, what kind of shape have we created? A squared. It's a circle, my goodness. It is. It's a rectangle. Good. It's a rectangle. So there are a couple of things that we know, right, about the rectangle that we've just created. What we know is that this side isn't going to be 1. This side is going to be 4. And have we not then just figured out the size of t? How big is t? T is equal to what? How much is t then equal to? Good. T is equal to the square root of 33 degrees. Okay. Now, does the question look that scary? Not really. Answer the question for me, please. The question says, determine the value of t squared without the use of a calculator and with the aid of a sketch. Now, why is it a rectangle and not a circle? Narisha, I'm a bit lost as to how you're seeing a circle, my darling. Do you want to unmute? Let's have a conversation. I don't want to leave you behind. Where is the proof? The answer is actually quite easy if you think about it now. Narisha, my darling, I'm not 100% understanding you quite yet. Can I ask you to elaborate a bit so that I don't leave you behind? Okay, I'll wait for your response, my darling. But okay, let's talk about this. We've now figured out that t is equal to the square root of 33. The question says determine the value of t squared. What would t squared be? Therefore, t squared must equal the square root of 33 all squared, which is then equal to just 33. Okay. All right, thumbs up. Are we okay with this question? Everybody okay with what happened here? Yes, I can explain again. Oh, the shape could be a circle for all I know because ma'am needs to prove that it is a rectangle. No, oh, not necessarily. Okay, so let me do it this way, Narisha. If I give you, I already know that my Cartesian plane is 90 degrees. Are we in agreement? Yes, this is 0 degrees, the x-axis here, and this is 90 degrees over here, and that's the y-axis. We're okay with the idea that that's 90 degrees? Yes? Okay, cool. All right. So if I'm now given an angle over here, let's say this angle over here is 40 degrees, right? If the other angle on the other side is complementary, how much must that angle be? I was 60, Kaizing. Hey, what's going on here? Thank you, thank you, princess. Oh my goodness, if they're complementary, they'll be 50 degrees, right? This one will be 50 degrees. So we automatically know that there is a right-angled triangle over here. It's okay, Abu, I know you're busy with 49 plus 1. Okay. All right. So remember what we normally do. When we are given this angle over here, they normally call it theta. The first thing we do, Narisha, is we drop this thing in that direction and we make this 90 degrees. Yes? We know this, right? Because this would be our y, this would be x, and this would be r, right? So now if I have to create another triangle on the other side using my complementary angle, I'm not going to draw a line that's parallel to my y-axis. I'm going to draw another line that is parallel to my x-axis. It'll be parallel to the x-axis, y-axis. Okay. And therefore, we have made a triangle. Because technically, I've taken two triangles and I've put them together. Does that make sense? And they must both be 90 degrees because we're using SOHCAHTOA. We're using sine, cos, and tan. Okay, and the only way we use sine, cos, and tan in grade 10 is when we have a 90-degree triangle. Okay, did that help, Narisha? I hope it did. It could be a square. It could, but in this case, we know it's not. Okay, this is how we know it's not. Because this side is 4 units long, and this side is root 33 units long. What would need to happen for it to be a square? What would we need? All the sides would need to be equal. Yes, we'd need equal sides, and it's unfortunate we don't have equal sides here. So it's automatically a rectangle. Okay. Cool with that? Amazing. Okay. Cool. All right. Let's look at 5.2. Again, I'm going to give you guys a few minutes to read. Pop an emoji on the screen. Ooh, my words are escaping me. It's probably because I'm on antibiotics. I don't know if that's a thing, but I just took an antibiotic because I just finished dinner, and so I think my body's just like, no, not happy, not happy. Skiski. I do. I sound like one of the Migos at the moment. Okay, read 5.2 for me, and then we'll chat. Okay. Sure. Happy to zoom in. There we go. It's not that bad. You always say that, Abu, and then you find it so easy. Oh, tell us, Didi Malheur. All right. Are we ready to answer the question? Yes? Well, more the other way around. More the other way around, Narisha. I'm glad to hear it. Okay, let's chat about it in just a little bit once we're done here, okay? Because I am curious. I want to know. Okay, but we'll chat in a little bit, Imala. All right. Okay, so I just want to double check. Thumbs up. Is everybody understanding how this question is actually going? Yes? Are we seeing it in any way, what we would need to do? Does anybody have an idea what we would do with 5.2.1? Thumbs up? Isn't. No? Sanela says yes. Okay, let's talk about this. Okay. I'm going to use a different example, and it's kind of the same thing, really. If I said to you that A is equal to 2, and then I say to you, I've got A squared minus 3 is equal to... No, yeah, A squared minus 3 is equal to something. What would my answer be? What's my answer? My answer is 1. Are we all in agreement? Yeah, it's 1. Right, because I'm going to go in there. Wherever I see an A, I'm going to replace it with a 2. So I'm going to end up with 2 squared minus 3. 4 minus 3 is equal to 1. Okay, so it's not that far-fetched a concept. Now, let's go have a look at this question over here. It says, assume that sine squared x plus cos squared x is equal to 1 for all the values of x. Now look at the first question. What does the first question start with? It starts with 1. So what are we going to replace there? Yes, is it clicking? Are we all okay? Can we find ma'am an answer? It's an easy answer, I'll tell you that. Very easy answer. Oh no. Oh no. It's okay. It's okay, Narisha. It's never that deep. Most times it's not. Okay, it's just about logical thinking. All right, anybody got an answer for 5.2.1 for me? It's not going to be sine x. It's not going to be trig triangles. Narisha says it's -1. Ah, Palissa's got the answer I'm looking for. That's the answer. All right, let's do an actual substitution. That's the answer, Sanele. Good. We're going to do an actual substitution. Where we see 1, we're going to replace 1 with that. Okay, with sine squared x plus cos squared x. So for 5.2.1, I'm going to get sine squared x plus cos squared x minus cos squared x minus sine squared x. That's going to equal, add like terms. Add like terms. Sine squared x minus sine squared x is 0. And cos squared x minus cos squared x is 0. So the final answer is 0. That wasn't difficult. You just put in the x. Okay. Well, you can do that as well. But yeah, that's pretty much the idea. That's pretty much the idea. So if you put in a value for x, they're not going to give you the mark really, because they want you to use the thing that they've given you to find the answer. I just want to make sure. Let me double check. Thumbs up. Does everybody understand how ma'am has approached this question? Yes? Lovely. Good. Okay. So let's look at the next one. 5.2.2 is a little bit more tricky. Okay. We're going to have to do a bit more calculating. Okay. So look here what they've given us. Over here, they've given us cos squared x. Over here, they've given us sine squared x, right? And over here, they've given us tan and cot. Now, if I want to compare all of these things to each other, I need them to be the same. Am I making sense? Yes? Good. We know that cot will be 1 over tan. Beautiful. Right. We know that. This is a cousin. We must change the cousin. Right. We know what cot is going to be. But not necessarily sine squared x or cos squared x. Okay, let's think about this. If we, not yet, Theo, no thumbs down just yet. If we go into this part, this equation that they've given us over here, right? If I've got cos squared x, I know that I now want to make cos squared x the subject of the formula. What needs to happen? If I want my answer to be cos squared x equals, I want everything else gone. Grouping is not going to help me here, Narisha. I only have 2 terms. Okay. My question really is, if I said to you, I've got 2 plus x is equal to 5, how do I get x on its own? What do I do? We transpose the 2. We take 2 over to the other side, right? We take 2 over to the other side. So maths doesn't change, guys. Nothing about mathematics is going to change just because there's a cos or a sine or a cos squared or a sine squared, right? Now, if I want cos squared x to be the subject of the formula, what would I need to do? Hello, Gift. We'll talk about that in just a little bit. Okay. Good. What would we do? That's it, Theo. We would take sine squared x over to the other side. So cos squared x ends up being 1 minus sine squared x. Is everyone still with me? Thumbs up. Are we good? Okay, good, Justin. Good. All right, 50-50. Okay, I'll do it this way. If I say to you, I've got A plus B is equal to C, and I want you to make A the subject of the formula, what would you do? You would take B over to the other side, right? B would go over to the other side. I don't know what the value of B is. I don't have to know the value of B. I just need to know that A is equal to C minus B. Does that make sense? I don't have to know what C is. I don't have to know what B is. As long as I know that I've got A on its own, then I've done my calculation correctly, or I've done my transposition correctly. Okay, does that make sense, Narisha? So now that I want cos squared x on its own, I don't have to know what sine squared x is. I just have to move it over to the other side so that I have cos squared x as the subject of my formula. Okay, now what's our next step? We're going to go into this formula, and what are we going to replace cos squared x with? We're going to replace it with what we've just figured out cos squared x is equal to. Okay. Abu, you look quite despondent. Okay, shall we do it together? Yes, thumbs up. Do you want to do it together? Good, and then we'll just add like terms. Okay, let's do it together. All right, so I know cos squared x is 1 minus sine squared x. So I'm going to go 1 minus sine squared x plus tan x. We said we're going to change cot x into times 1 over tan x. I'm going to move over just a little bit, plus sine squared x. Let's clean this up. Let's clean this up. I know that tan x and tan x will cancel each other out. So technically, I've got 1 minus sine squared x plus 1 plus sine squared x. And then all we need to do is add like terms. Can you guys add like terms for me? Give me an answer. It's not 0 this time, Theo. Look properly. That's it, Narisha. Good, that's it. That's it. Good. I know that negative sine squared and sine squared will cancel each other out. So I've only got 1 plus 1 left, which is equal to 2. Okay. So these questions are not that difficult, grade 10s. We just really need to think a little bit outside the box. Okay, how are we feeling? Would we like to try? I've got a graph. Shall we look at graphs? Yes, how do we feel about graphs? 50-50. 50-50. All right, let's remind ourselves of a couple of things. All right, so we need to know that when we are looking at sine, cos, and tan graphs, we need to remember the period. We need to remember the amplitude. Okay, the range is quite important. I hope I'm not forgetting anything. Yeah, the period, the amplitude, and the range. Okay. Okay, let's talk about the period. What is the period? It's how long intervals. I'm not sure. Oh, okay. Well, we can add an asymptote for the tan graph. Okay, an asymptote for the tan graph, but that's not quite important. All right, good. The period of any sine or cos graph needs to be 360. What is the period? It's how long it takes for my graph to complete a full revolution. Okay, so or to complete the shape of the graph all the way around. Okay, so the amplitude of my graph will be how high it goes or how low it goes. The normal amplitude of a sine and a cos graph should be 1. Sorry, the period of a tan graph should be 180 degrees. Okay, and it's because there are problematic things when we get to asymptotes, right? So the amplitude of sine and a cos graph should normally be 1. A tan graph has 0 amplitude. Tan graph, no amplitude. Okay, then the range of our graphs will always be from where y is at the lowest point, is in between the lowest point and the highest point. Okay, and again, the range of my tan graph is always y as an element of all real numbers. Okay, because if you look at my tan graph, it looks like that, which means it'll go on forever and ever in the y direction. Okay, so y is an element of all real numbers, so it doesn't really mean, we don't really get anything like a high value and a low value for that. All right, yes, forever and ever. Okay, so our asymptotes only exist in a tan graph, and they exist at the points 90 degrees and 270 plus really any plus k times 180. Any of these two values, and if you add 180 to that plus 180 plus 180 plus 180, you always end up hitting an asymptote. Okay, all right, screenshot this. It's quite important. We're going to have a look at it in just a bit. All right. Okay, I'm just going to add one more thing before we go quickly. Okay, so if we look at our original sine graph, sine theta, we know that sine graphs start at 0, go all the way up to 1, come down and back again, right? This is 360 here. This is 180 here. We know that that's 90, and we know that this is 270. At 270, my graph is at -1. At 90, my graph is at 1. Okay, and over here, this is 0. This is the sine graph. Let's look at the cos graph really quickly. I know that my graph will start at 1, go down, come up, go down, like that. This over here is at 360. This is at 90 degrees. 0 degrees is at 1. And here in the middle, at 180 degrees, we are at -1. Okay, this point over here is 270 degrees. All right, and that's how our cos graph looks. I think these are the two that we need for now, and then we'll have a look in just a bit. All right, let's look at this question over here. Okay, and I want us to interact with this question as much as we can. What we're going to be asking ourselves is, what do we see? What do we see? Let's start there. Okay, what do we see? They say here that the diagram below represents the graphs of f of x is equal to a sine x and g of x is equal to b cos x. All right, where x is in between 0 and 360. Okay, so let's look at what's happened. Look at our sine graph. We are told that the graph of f is the sine graph, which means it's that one. Okay, it's that one over there. Okay. Oh, wow. Oh, wow. Sure, Sanele. Sorry about that. All right. How do we know? How does ma'am know? Actually, yeah, they'd have to tell us in this case. Theo, are you confused as to why it's the sine graph? Okay, so I'm glad that we're okay there. All right. So if we look at, sorry guys, just give me 1 second. I don't know what's going on with my controls over here. Okay, if we look at this, look at the original graph of sine theta. It goes up and then down and then up again. What's different in this one? This one is good. It's negative, right? It's been inverted. It goes in the opposite direction. Good. Good, Narisha. I'm glad that you're noticing. It's been flipped. Do we notice that? It's been flipped. Right. Now, we can see that it starts here, goes down instead of going up. So the original graph would be positive sine theta. What do we know about this particular graph? This one would be negative sine x. Right. So we already know that this a value over here needs to be a negative value. Now, normally, when we have the normal graph of sine theta, if there's nothing there, that means this is positive 1 because it goes all the way up to 1. But in this case, it's been flipped, and instead of going to -1, how far down does it go? It goes to -2. So this a value over here, a would have to be -2. Okay, are we all in agreement? Is everyone okay with that? Yes? Good. All right. So we need to be able to see those kinds of things. Okay, remember to keep the original graph in your mind. Okay, let's go look at the graph of G. G says we want B cos of X. So if we look at our original cos graph, we know that this is +1 cos X. There's an amplitude of 1. Right? It goes through 90 down to -1 at 180 and up to 270 and then back up to 360. What do we notice about this graph? It does the exact same thing, right? It starts at 1, wrong color. It starts at 1, goes all the way down, straight past 90, down to -1 at 180, through to 270 and back up to 360. So what is the value of B over here? What would the value of B in this case be? Good. The value of B is 1. Good. B is equal to 1. Okay. I know before I even look at my other questions that I've answered some of the questions that they're about to ask me. Okay. Let's go have a look at the questions. Right. I'm just going to zoom out a little bit. Sorry. Okay. Look at question 6.1. Question 6.1 says, write down the values of A and B. How boring. You understand? Yes, it is nice. It is quite like that. And I'm glad that you remember that it's a mother graph. Okay. So we're already done with 6.1. We've just figured it out. We've figured out that A is equal to -2 and B is equal to 1 by comparing them to the original graphs, by comparing them to the mother graph. All right. Let's talk about 6.2. Okay, I just want to double check. Can you guys give me a thumbs up? How many of you guys were there when ma'am was explaining the idea of an increasing and a decreasing graph? Do we remember how that looks? Yes? Yes? Okay, lovely. I'm going to remind us just one more time. Okay, it says here, for which values of X will G be a decreasing function? So we're going to the value we're going to the graph of G, which is the cos graph, and we're going to look at where my cos graph is decreasing. Okay, find me that interval, please. Where is my graph decreasing? Good, at 90 degrees, but that's not the only place, is it? Okay. So have a look, Sanele. Here's what I mean. If I start there, do you see how my graph is going down, down, down? It's still going down, 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 until it gets to good, until it gets to 180. Right, until it gets to 180. Okay, so for which values of X is my graph decreasing? It needs to be between 180 and which other value? Which other value is it in between? Not 90. Remember, it was still decreasing when we came this way. It was going down, down, down. Even here, it's decreasing. So where did it start decreasing at? That's it, Sanele. It started decreasing at 0. between 0 and 180. All right, thumbs up. Are we okay with the answer here? I'm sorry, Narisha. Sorry, Majala. It does take practice. Okay. All right, let's look at 6.3. Are we all able to answer this question? It's quite easy. What is the amplitude of F? Good. That's it. 1 mark. Easy 1 mark. How high up does it go? It goes up 2 units. So the amplitude of F is 2. Okay. All right. Now it says here, what is the range of G? What is the range of G? So the range is our, a range is our Y values, right? So I know that Y needs to be in between. Sure, I'm sorry, Narisha. Y needs to be in between 2 particular values. How high up does the graph of G go? It goes up to 1 and down to -1. You must include it. Abu, it must be greater than, less than or equal to. Okay. It must be less than or equal to. Because if you don't write the equal to part, what you're technically telling us is that there's an open dot at that spot there. And there's an open dot at that spot there. That's not true, because remember, greater than is just an open dot, and then greater than or equal to is a closed dot, which is what we have here. All right. Okay. Shall we look at 6.5 really quickly? Okay. So 6.5 says, 6.5 says, for which values of f of x minus g of x is equal to 2? Which values in that spot are equal to 2? All right, I want us to look at this question as it's been given to us. Which graph is f of x? We're going to use the graph instead of actually calculating. I think that's a grade 11 thing. Which graph is x or f of x? Is it the sine graph or the or the cos graph? Good, it's the sine graph. So we want to take the sine graph minus g of x is our cos graph, and we want the difference between the two of them to be 2. The difference between the two graphs must be 2. And now, because f of x is the y value and g of x is the y value, we can't look at it in this direction, not horizontally. It needs to be vertically that we're looking at it. Okay, so we're looking for a spot where the difference between the two graphs is 2. Can we find it? Where do we see? I see 2 spots. Good, at 270, right? Good. From there to there, that's 2. This is 0. So we know at x is 270. Good. Where x is equal to 270. Where else? And I see Abu's got it on point. Good. Where else? At 90 degrees. Thumbs up. Does everybody understand why at 90 degrees? Yes? Okay. Because if I did it in this direction, I would have to say f of x. Ooh, I'm lying. Sure, guys, why is ma'am lying? Okay. The reason I'm lying is because we said that we want the sine graph minus the cos graph. What do we notice at 90 degrees? At 90 degrees, it's cos minus sine. So that one doesn't count. The only one that counts is there, where we have the sine graph minus the cos graph. So only at x is equal to 270. Okay. And I'm trying to see if there's maybe another spot where I've missed it. Yes, I was testing you and you passed. Well done. Well done. All right. That was quite an easy question, actually. I don't think it was that difficult. How are we feeling about this question? Pretty okay? I don't think it was too bad a question. I am not covering my tracks. Okay. All right. Okay. I'm going to give you guys the option now. We can either do an applications question or we can look at another graphs question. I have a really nice tan graph question. Do we want to look at that? Or do we want to look at elevation and depression? Those are your two options. The wavelength one. Okay, I'll take a vote. Let's see how many people in the chat graphs. Okay, Javiso says graphs. Justin also says graphs. We could do rock, paper, scissors, Theo, but who am I going to do rock, paper, scissors against? So I don't think that really helps me because I don't have anybody to help me with rock, paper, scissors at the moment. It's unfortunate. Okay. Camera's on. All right, let's find you a tan graph we can use. Okay. I can't, okay, Justin, I can't actually, oh, maybe instead of doing that, maybe let me flip a coin. How about I flip a coin? Yes, but I feel like the graphs have it. I feel like the graphs have it. Yeah. The graph people have it really. Coins are scammers. Coins are scammers. Wow. Okay. Shame, guys. Yeah, I think the graphs win. We're gonna go look for a graph question. Okay. Okay, my computer always fights me around this time when I need to go find a question that will really help us. Okay, here's another nice one. Okay, it has kind of sort of the same questions, so I'm hoping that we'll take it in our stride. Okay, let's see if you guys are able to figure this one out without me. Sure. Guys, I don't know what it is with technology, but technology has never loved me. It's been the enemy of, it's been the enemy of my life, my whole life. I don't know why technology is just never my friend, guys. Technology is just never my friend. Okay, so here's the question. I'm going to leave it on the screen for a bit, and you guys can have a look at it. Okay, and let me know what you think. Okay. There's the question. Thumbs up. Are we able to answer this question? Look at the graphs. Look at the questions. Look at the information they've given you up top. Yes. Okay. You've got, it's a lot of questions. I'm going to give you guys 6 minutes to get up to there. Okay. As a matter of fact, I feel like we'll be able to answer 6.5 before we are really sure about how to answer 6.4. So let's answer 6.5 quickly and then we'll carry on. Okay. Sir, ma'am, we are not waiting. We are doing the questions. Come on. All right, there's less than a minute to go, but let me know if you need a little bit more time. All right, can we discuss the answers? Are we ready? Good, just in time, Narisha, lovely. Okay, so let's read the information we've been given here. The graphs of f of x is equal to a sine x. So we know that the sine graph is f of x. And g of x is, oh, they forgot an equals. G of x is equal to cos x plus 1 is given for our period, which is from 0 to 360. So we've got those two. Okay, let's start with the easy question. Let's look at our graph of f. Okay, look at our graph of f, and we know that a is then equal to 1. Good, because this looks exactly like the mother graph. Nothing has changed. It looks exactly like the graph of sine theta, which means that the value of a over here, it must be equal to positive 1. Nothing has changed, nothing. Okay, if we look at our cos graph, we're not 100% sure what's happened. Okay, not yet. But if we look at it carefully, I'm seeing a hand up. If anybody has a question, I'm happy to take a question. It's a mother graph, right? It absolutely is. But one thing I want us to be very aware of, right, is if, let's say, for instance, they give us the graph of sine theta minus 2. Okay. This minus 2 has not only moved the graph down by 2, it's taken the x-axis with it. Okay, so if my graph is being drawn, good, Theo. If my graph is being drawn, then the x-axis must also go to minus 2. Okay, so here's what I mean. If we look at this question they've given us over here, they've told us that cos x or g of x is cos x plus 1. Now, normally, my x-axis would be over here. But because they've lifted the graph of cos x by 1, we're going to take the x-axis and we're also going to move it up by 1. So technically, my x-axis for the graph of g is over here. Thumbs up. Does that make sense? Everybody okay with that idea? Yes? Good. So as soon as they lift my graph by 1, my x-axis will also lift by 1. Now I can assess my cos graph accordingly. Now I know that my cos graph, if this is 1, that's lifted 1. So it's starting in the right place. And then it's moving through all the points where it normally would move if it was sitting at 0 on the x-axis. So technically, this graph that we have of G is a mother graph. It's just that they've shifted the mother graph up by 1. Okay. All right. So let's start with the easy answer. Write down the value of A. You are all correct. A is equal to 1. Write down the range of G. Okay. So now Y, my Y values for G. Okay. And Theo, you are spot on. The highest point is at 2. And the lowest point of my G graph is at 0. So those are my points. But remember, guys, it's always less than or equal to, okay, on both sides. All right, it says determine the amplitude of G. What is the amplitude? Well, it's not going to be 1. Remember, Theo? It's not going to be 2. You've also lifted the x-axis. So we just want the distance from there to there. What is the amplitude? That's it. The amplitude is positive 1. You don't even have to say the positive part, Sanele. The amplitude of G is 1. That's all you need to write. Okay. Or, you know, if you want to be ceremonious about it, you can say amplitude equals 1. Yes, you're allowed to do that, Narisha, and that's perfect. You've done your interval notation proper. That's it. Yes, absolutely, you can do that. Well done. You're allowed to do that. Excellent. Okay, let's talk about 6.4. All right. Let me just double check. Thumbs up. Are we all able to do 6.5? We've just done a question just like it before. Yes, we should all be able to do this. I'm sure we should. We know that we look for the graph of g of x. G of x is the cos graph minus the sine graph. The difference between the cos graph and the sine graph must give us 2. So can you guys find me those points for x? X will equal which point? You write them with commas in between. Which points on the graph will there be a difference of 2 where g is on the right spot? Good. So from 0, right, I know at 0 degrees, from 2 to there, right, so 0 degrees, comma, and then we go look elsewhere. Okay, that part doesn't count because f of x is greater than g of x. There we go. All right, we see g of x there. That's my cos graph minus my sine graph. So again at 270 degrees. And then where else? I can see at the very end. Good, that's a Jaden. From at 360, there's g of x and there is f of x. All right, so at 360, at those 3 points. And there you go, at 3 marks, because we know what we're doing now. All right, so let's look at 6.4, and then I'll let you guys go because time actually is up. 6.4 says, for which values of x will f of x be greater than g of x? So where will my sine graph be greater than my cos graph? In the y values. So we just need to go look for the parts where my sine graph is above my cos graph. Do we see it? Yes. There, right there. That's my sine graph bigger than my cos graph. Everywhere else, my cos graph is bigger than my sine graph. So I will write x needs to be, oh, and I can't include, oh no, I must include it. X must be in between 180. And which other point must it be in between? Between 180 and 90, that's it. Between 90 and 180 degrees. Okay. All right, let's do 6.6 quickly, and then I'll let you guys go. All right, this last part says, the graph of f is reflected across the x-axis. So we know that we are using the x-axis as our mirror. Right. It's reflected about the x-axis. So my x-axis is the mirror. This is my mirror. Oh, I don't know what I did there. There is my mirror. And they're saying the graph of f, which is my sine graph, right? Yes, that's it. So I know that it's that graph there. It's being reflected, which means that point will reflect and sit on this side. This point will reflect and sit on that side. And now my graph will just go in the opposite direction. Just like that. And hopefully you draw a lot better than I do. Right. So what's the difference between this new graph and the mother graph? We've just taken that positive one that we had and we've made it negative. Right. So I know that my new graph that they want, write down the equation of the new graph h is just going to be h of x is equal to, where the original graph was f of x is equal to 1 sine x. I know that if we flipped it this way, my new answer will just be h of x is equal to -1.